Hello legacy students, today we're going to talk about the first form of graphing quadratics. Today we're going to embark on a new adventure in math, basically something that's not a line. We're going to actually start graphing them. Your learning objective, I can graph a quadratic equation that is in standard form. So first thing, what does it mean to be in standard form? Well, standard form is y equals ax squared plus bx plus c. It's what you normally saw when we were factoring the last unit. These equations will graph into a U shape, which you have seen and have heard it's called a parabola. So a parabola is when we have a U shape. Now there's various parts of a parabola that we need to keep in mind. So just like our V's for absolute value, each parabola has two sides and a turnaround point. They kind of have a reflection look to them. This point is called the vertex. So your vertex, guys, is the bottom point. It's what's known as your turnaround. So notice here it's this point right here at 2, -4. Right there, it would be my vertex. You also have roots or x-intercepts or zeros. Those are also known as your solutions. So when we were solving last unit, those were when we found x equals 5 and x equals 2. Those would be your two intercepts of your graph. Then there's also something that we did not use for our V's, but you could have still found them, was known as the axis of symmetry. That is a line that cuts through the vertex. It's where you can fold the parabola perfectly in half. So we will identify that on every parabola that we graph during this unit. Some properties of standard form to get to know. One thing we're going to talk about a little bit is called concavity. What it means you have concavity, it means that which way does the graph open, really. So if your graph is concave up, it's when your A is greater than 0. What that's going to look like is your U is going to look like a upwards facing U, up like a cup. Graph is concave down when your A is less than 0, because remember guys, we have the equation ax squared plus bx plus c. So when my A is greater than 0, I'm going to have upwards facing U. If it's concave down, that is going to be a downwards facing U. Down like a frown. Something to keep in mind. To find our vertex, what we're going to do for the x value is we're going to use this cute little formula here, negative b over 2a. Yes, it does come from the quadratic formula. And we're going to pick out the b and the a from our equation. That's going to give you the x value. Now, if you want to find the y value vertex, basically you take the x value you just found, plug it into the equation, and you should be able to go from there. Now, let's grab that handy dandy note sheet I gave you during class today. So graphing quadratic functions in standard form. The ones we're going to first graph is f of x equals x squared minus 4x minus 5. Now, this f of x, guys, that is just y in fancy terms. I'm just putting it as an f. So the very first thing, let's find our vertex. So I gotta do the negative b over 2a business. So my b is -4. So it'd be a -4 over 2 times my a, which is 1. So it would be 4 over 2, which is just 2. Right? Now your vertex is going to be written as an ordered pair. So my vertex, my x value of my vertex is 2. To get my y value, I'm going to take that 2 and plug it into this equation. So I'm going to get 2 squared minus 4 times 2 minus 5. So 4 minus 8, it's -4, minus 5, -9. So I'm going to have a point for my vertex of 2, -9. Now, guys, since this is a parabola, you want to put your vertex in the middle of your table when you're graphing in standard form, because your vertex needs to be in the middle, right? So I'm going to have 2, -9. Now I need some numbers around 2, so I'm going to go 0 and 1 and 3 and 4. So if I plug in 0, I'm going to get 0 squared, which is 0, minus 0 minus 5. So that's going to be -5. Plug in 1, I get 1 minus 4. That's -3 minus 5. That's -8. 3, I get 9. minus 12, that's negative 3. Negative 8. Notice, guys, this is matching. That should happen. 16 minus 16, that's 0. Negative 5. Another match, which is perfect. That's what should happen because they do have symmetry, your parabola. Let's graph these points now. So I got 0, negative 5, dot right there. 1, negative 8. 2, negative 9. 3, negative 8. And 4, negative 5. There. There we go. There is my graph. Now let's answer a couple more questions here. What is your concavity? Are we up or are we down? So it's going upwards, right? So I am concave up. My axis is symmetry. Now notice, guys, if I would fold my parabola right here on the line I'm drawing, I would be able to fold it perfectly, right? And the equation of this line that I just drew would be x equals 2. So that would be the axis of my symmetry. X equals 2. That's a line that would draw this particular line right here. Alright, so what do we mean by end behavior? End behavior means what is it doing on the left hand and what is it doing on the right hand. So we're going to have some funky way to write this though. So as x goes to negative infinity. So as my x is approaching or going towards negative infinity, what's happening? So if I go towards negative infinity, which is this way, right? My graph is going up. Would you agree with me? My graph's going up. So then I'm going to say my y is going towards infinity. Now let's write on the other direction. So as x is growing towards infinity, what is my y going to do? So as x is going towards positive infinity, which is this side, it looks like my graph is still going up, right? So y is going towards infinity as well. Something to keep in mind, guys, that's what end behavior means, is what does the left-hand side doing is what in the right-hand side doing. Now let's answer the rest of the questions as well. So my y-intercept, how are you going to find that? What that means is where is it crossing the y-axis, right? So if your graph does not show it all the way, which I believe ours did, it showed it right here. So at negative 5, right? But if your graph is not showing it to you, what you're going to do is plug in 0 for x. And then you're going to get your y. So if I plug in 0 for my equation, I'll write it up here so I can remember, I'm going to get 0 squared minus 4 times 0 minus 5. So I'm going to get 0 minus 5, which is negative 5, right? So my ordered pair will be 0, negative 5. That would be my y-intercept. Now, what about your x-intercept? Where are you crossing the x-axis? Well, on here, we kind of just got these points, right? We didn't get the x and y, the x-intercepts. How are you going to find them? Well, that goes back to our last unit when we solved quadratics. Those were basically finding the x-intercept. So, x squared minus 4x minus 5. How would we solve or find the zeros or the roots of that equation? Well, you are going to set it equal to 0. Okay, now I need to solve this equation. How am I going to solve that? I wonder if it's factorable. So that'd be 1 times negative 5. Numbers that make negative 5 but add together to give me negative 4. Negative 5 and 1, right? That'll give me negative 4. So I can factor this into x minus 5 and, ooh, my 5 disappeared. X plus 1. So x can equal 5 or x can equal negative 1. Those are my two x-intercepts. So I'm going to write them as ordered pairs, 5, 0 and negative 1, 0. Not much different, just like what we did last unit, but this is using it in the graphical sense. So I know those two ordered pairs are on the graph that we just made. Now, domain and range, we covered that earlier. If we look at our graph here, guys, my x values, I get all the negative x's because this is going to keep growing on this side. It's going to grow all the way in the positive x. So my domain is from negative infinity to infinity. If I look at my range now, it looks like I'm starting at negative 9 and I'm going to the positive as evidenced by my end behavior. So I'm starting at negative 9 going to infinity, because remember, range is bottom to top. Now, where are you increasing and where are you decreasing? Remember, guys, that was with the car, right? So if I have my car here, looks like it's going down until I hit this x value, which is at 2. So I am decreasing from negative infinity, because we're talking x values, right, to 2. And then I'm going to increase from 2 to infinity, because you're talking your x values. Let's try one more example with this as well. So I have this parabola. Oh, wait, I did not answer. Is it a maximum or a minimum? Forgot about that. Right down here. It is a minimum. Circle that. Because it is a upwards facing U, my concave up. That means I have a minimum. Forgot about that to answer that. You guys are probably wondering. Okay, let's go ahead and make our table here. Actually, let's find our vertex. So I have negative b over 2a. So that'll be 2 over 2 negative 1, right? Because my a is negative 1. So I have 2 over negative 2, which is negative 1 for my x. If I plug that in here, I'll get negative 1 squared minus 2 times negative 1 plus 8. So negative 1 plus 2 plus 8 should be 9, right? Place that in the middle, so I get negative 1, 9, negative 2, negative 3, 0, and 1. 0 is 8. 1 is negative 1 minus 2 is negative 1 plus 7, or plus 8, that should be 7. Oh, hold on. Negative 1 minus 2 is negative 3. Oh, that's 5. I can't obviously add. That should be a 5 there. And then I know, based on parabolas, that it should go like that, right? So I can go negative 3, 5, negative 2, 8, negative 1, 9, 0, 8, 1, 5, down like that, down like that. Okay, I am concave down, because it is down like a frown. My axis of symmetry, I can fold perfectly on right here, right down the middle, which is at x equals negative 1. I have a maximum, because it is upwards, right? My ebb behavior, remember there's two parts we want to know about. As x approaches negative infinity and as x approaches infinity. What's happening? So as x approaches negative infinity, which is on this side, notice we're going downwards. So I would say y is approaching negative infinity. Same thing on this side. As I'm going to the positives, it looks like I'm approaching negative infinity on the y's as well. Those are my two n behaviors that I have present. Okay, let's find the rest of our answers here. So my y-intercept, we did find it right here as we plugged it 0. So it looks like my y-intercept is at 0, 8. My x-intercept, however, I do need to find them. It looks like on my graph it should be negative 4 and 2, so let's see if that's what's going to happen. I need to factor, I think this will factor. So I have negative 8, right? Because a times c will give me negative 8. That'll be negative 4 and 2. Now be very careful, guys, since that a is a negative 1, we do need to do some grouping right here and right here. So I'll get negative x, and a positive 2 out of there. So I'll get negative x plus 2 and x plus 4. Or x equals negative 2. Or nope, that should be a positive 2, shouldn't it be? Because negative 2 plus 2, yeah, that would be 0. And x could equal negative 4. So my two ordered pairs, 2, 0, and negative 4, 0. Those would be my two x-intercepts as evidenced by my graph on the right there. My domain, notice guys, it is going for infinity and infinity. Something to keep in mind, guys. Domain for a quadratic, any kind of quadratic, is going to be negative infinity to infinity. There are no issues with your domain at all. Range, bottom to top, so I start, looks like it's going forever this way, so I'm going to start at negative infinity. It looks like I'm stopping right here at y equals 9, right? So 9. Increasing interval, I am increasing from, if I draw my little car here to my middle point, negative 1. So I'm increasing from negative infinity to negative 1, because remember guys, this is talking x values. And then I'm talking from negative 1 to infinity for decreasing, because I'm going to keep going down forever. And that's the end of this video. See you later, Sabers.